morning everyone, welcome to Bytecode Technical Solutions. So today in this video we are going to discuss about stack applications. So in the previous video we saw about the introduction to stack, what is actually the stack is, we understood the definition of the stack, we understood various different operations of the stack such as push operation, pop operation, display operation, and also other couple of two conditions we understood, that is whether the stack is overflow or whether the stack is underflow, based on which we are going to conduct the push operation or pop operation. Okay. So the content of this video are as follows. So in this video we are going to cover up the applications of the stack, including conversion of expression, evaluation of expression, recursion, and other applications whatever that are eligible we can perform with the stack. So first one, conversion of expression. Whenever we write any mathematical expression in a program, we basically use a type of expression called as infix expression. So these expressions will be converted into equivalent machine instructions by the compiler using stack. Here the stack plays a very vital role in the conversion process. So using stacks we can efficiently convert the expression from either infix to postfix or infix to prefix. In the upcoming slides we will come to know about what do you mean by infix expression, what do we mean by postfix expression, or what is prefix expression, and so on. Okay. Next, evaluation of expression. So basically the arithmetic expression will be represented in the form of either postfix or prefix. These expressions can be evaluated very easily with the help of stack. Definitely we will be going to understand about it in the upcoming video. Next, recursion. We know that a function which call itself is called as a recursive function. So there will be some of the problems like tower of Hanoi, problems involving tree manipulations, and some any more applications. These all can be implemented very efficiently using recursion application. So it is very important facility available with variety of programming languages such as even C, C++, etc. Other basic applications what the stack will help in, so might be like, for example, if we want to find whether the string is palindrome, to check whether the given expression is valid or not, and so on, we will apply the stack, we will use the stack. Now let us understand about conversion of expression in more detail. Before going in detail about the conversion of expression, let us first understand what is an expression and what are the various types of expressions available. Okay. So the sequence of operators and operands that reduces into a single value after evaluation is called as an expression. Okay. So here the operands consists of constants and variables, whereas the operators consists of various symbols. It might be either positive symbol, it might be negative symbol, it might be multiplicative symbol or division symbol, and so on. The operators here indicates the operation that is to be performed on the operands, what is being specified. Okay. So for example, you can see on the screen a plus b is an expression what we are taking here as an example. Here a and b are the operands. A is operand number 1, b is operand number 2, and the plus symbol used as an additional operator that is going to add the elements of a and b. Okay. So this is an operator. Next, let us understand how these expressions can be classified. So these expressions can be classified into three types. That is what you are observing on the screen: infix expression, postfix expression, and prefix expression. The categorization is based on the presence of operators within the operands. Okay, the presence of operators with the operands. So based on that, the expressions are categorized. Let us understand first the infix expression. In an expression, if an operator is in between two operands, then the expression is called as infix expression. Here in this infix expression, the infix expression can be parenthesized or non-parenthesized. Parenthesized in the sense the expression is within the parenthesis, and non-parenthesized means parentheses are not being available in the expression. Okay. So here a plus b, the first expression what I am pointing with the pointer here. So this is unparenthesized expression, and the second one is the parenthesized expression. Here as usual a and b are the operands and plus is the operator. So here in the infix expression you can observe the plus operator is being available in between two operands, in between the two operands a and b. So it is in between, hence it is called as infix expression. Next, what is postfix expression? So in an expression, if an operator follows the two operands, okay, if an operator follows the two operands, it means operator comes after the appearance of the two operands. Okay, so this type of expression we say it as the postfix expression. Here parentheses are not allowed or not being used in the postfix expression. The postfix expression is always unparenthesized. Okay, so here you can see in an example the plus operator is appearing after the operands a and b. Okay, so plus operator is appearing after, hence it is called as post appearance of the operator, hence the name postfix expression, hence the name postfix expression. So based on this, it is also called as suffix expression, or another name we will say it as reverse Polish expression. These two terminologies you need to remember it, as because these are important interview questions. So suffix expression we also call for the postfix expression, and even we will call the postfix expression as the reverse Polish expression. Next, what is prefix expression? So prefix expression, in prefix expression, if an operator precedes the two operands, that is, if the operator comes before the appearance of the two operands, then that type of expression we call it as the prefix expression. Here in the example you can see the plus operator is appearing before the appearance of the operands. A and B are the operands. Before that, plus operator is being displayed. So this type of expression is called as prefix expression. So here this expression, prefix expression, is also called as Polish expression. Okay, it is also called as Polish expression. These terminologies, please remember it. The prefix expression is also called as Polish expression. Okay, right. So, and another one thing to be noted is the prefix expression is always unparenthesized, as accordingly like postfix expression, prefix expression will also be unparenthesized. So next we are going to check out about what is precedence and associativity of the operators before going to learn about the conversion of expression from either to infix to postfix or infix to prefix. So here we are having some table. So in this table we are having operators being listed, providing their associativity and precedence values, that is priority values. Okay. So before going in depth with this table, let us understand these terminologies. What actually you mean by precedence of the operator? What are the different operators? If they have same precedence, how we can evaluate, or how we can convert, or how we can consider, and what is the associativity of the operator? Okay. So let us understand these three questions. So first one, as accordingly, what is the precedence of operator? So these are the set of rules that determine the order in which different operators are evaluated. Okay, the way in which the operators are evaluated, these are called as the precedence rule or precedence of operators. Normally we associate some value that is to be determined the order in which these operators have to be evaluated. So highest precedence operator will be having the highest value, the lowest precedence operator will be having the least value. The table what we have seen in the previous slide, so here we have different operators with the priority values or else the precedence values. The highest the precedence value will indicate the highest precedence operator. So you can see here exponential, that is a dollar symbol and a raised to symbol, basically we call it as a caret symbol. So these two have the highest priority, that is 6. Okay. Then next comes the multiplication, that is asterisk. Okay, it is having the priority 4. Next the division symbol, okay, it is having the priority 4 again. Then modulus operator is there, modulus symbol is there, percentage symbol, so we again have the priority as 4 itself. Next addition symbol, that is plus, it is also having priority 2. Subtraction minus, it is having the priority 2. So next question is, what if we observe two operators are available in the expression with the same precedence? At that time what we have to do? So during the evaluation process, if 2 or more operators appears in the same precedence, then the precedence rules are not applicable. Hence, why? Because they are having same values. Instead of this precedence values, we do consider the associativity of the operators at that time. Okay, we consider what? We consider the associativity of the operators. Now, what is this associativity? So the order in which the operators with the same precedence are evaluated in an expression is called as associativity of the operators. Associativity of the operators. Now consider an expression like, for example, 8 plus 4 plus 3. Here we have plus operator being appeared 2 times, 8 plus 4 plus 3. So this plus operator is having the same precedence. Okay. So which one has to be evaluated plus? Either we have to do add 8 plus 4 at the first stage, or we have to add 4 plus 3 at the first stage, and then at the second stage do we need to add 4 plus 3 with the 8. So here it is little bit confusing. Hence at this stage associativity of the operators will come into existence. So associativity, according to the table what we have saw in the previous slide, so if there is the existence of plus operator 2 times in the same, the associativity says that you have to solve the expression from left to right. Okay. So first we will consider 8 plus 4, that results into 12, and this 12 is being added with 3. So we will get the single expression, single value, that is 15. Okay. Like this we can solve the expression. Okay. Right. Now let us go for checking out the first type of way of converting the expression, that is infix to postfix. So for understanding this, we will consider the same precedence table what we have saw in the previous slide, and we will try to apply it mathematically. So like this. So here we have this expression to be parenthesized. Here we have parenthesis. So we will convert this infix expression to postfix expression. So when it is having the parenthesis, the innermost parenthesis will be taken as the highest priority, even though there are the operators with higher priorities outside that of that inner parenthesis. Then also we will consider the inner parenthesis to be evaluated first. Here inner parenthesis is b minus c. So this is being taken as T1. Okay, you can check it out here. The T1 means what? B minus C. So if we convert it to postfix, that results into BC minus. Okay, we are substituting this B minus C as T1. Okay, and we are keeping ready by converting the T1 expression into its postfix form. Okay, Then next this b minus c is taken as t1 here as substituted. Next innermost parenthesis will be having the expression a plus t1 star d. So here plus and star, or else you can say like asterisk, which indicates the multiplicative index. Okay, the plus and asterisk both are available. Among these two operators, which one is having highest priority? So you can just check it out by going back to the previous slide for the table. So multiplication is having the highest priority than the plus symbol. So multiplication priority is 4, whereas plus symbol priority is 2. Hence we have to go for multiplication first, and later on we will go for the addition. So here t1 star d or else t1 asterisk d will be taken as the first evaluation. Okay, so this will be taken as t2. So t2 means what? T1 star d. So once after converting it into postfix form, it results into t1 d star. Okay, next. So the next parenthesis, innermost parenthesis will be a plus t2. Okay, a plus t2. So we are going to evaluate the a plus t2. We will substitute it as t3. So here a plus t2 is converted into postfix form, that is a t2 plus. Okay, t3 is taken as a t2 plus. Next we have the expression to be evaluated is t3 raised to e plus f. Here raised to symbol or else the caret symbol is having the highest precedence. Hence we will evaluate and substitute it as t4. So t4 is nothing but t3 raised to e. So converting it into the postfix form, it will be t3e raised to. Next. So remaining is t4 plus f. We will directly keep it as t4f plus. Okay. Substitute now all the values of the t4, t3, t2, t1 and so on. Now here t4 is here t4 we are taking it by what? T4 we have taken it as t3e raised to by replacing t4 t3e raised to. So t4 in the place we have to keep what? T3e raised to symbol. Then f will appear as it is and plus will be kept as it is. Okay. Now substitute the value of t3. What is the value of t3? It is a t2 plus and again keep e as it is, caret symbol as it is, f symbol as it is and plus symbol as it is. Then next here we have to substitute the value of t2. So t2 value is what? T1 d star. So here it will be a t1 d star plus as it is, e as it is, raised to symbol as it is, f as it is and plus again as it is. And finally we have to substitute the t1 value. So t1 value is what? Bc minus. So finally we will get the expression as a bc minus d asterisk plus e raised to symbol f plus. So this final expression what we got is the equivalent postfix expression that we got it from the infix expression, this one. Okay, right. So this expression was with the parenthesis. Now let us consider similar another infix expression without parenthesis. Okay, without parenthesis. So in the parenthesis case, what we used to do is the innermost parenthesis will be taken as for evaluation at the first stage. So here in this expression without parenthesis, there is no any problem. So just we need to check out the precedence of the symbol of the operator and then we have to evaluate. So here in this expression, first we will consider y $z. Why do we take it as here? What is the expression? It is x dollar y $z. So go back to the particular table. You can observe that the exponential operator dollar or raised to, if it is appearing, it is having the highest priority, that is 6. Rest of the other operators will be having the lowest priority. Among that, asterisk, division and modulus having the priority as 4, whereas the plus and minus are having the priority as 2. Okay, so as this dollar symbol and then the caret symbol is having the highest priority. Okay, so in the same way we will do consider here. So here dollar symbol will be evaluated first, but here the question is the dollar symbol is appearing 2 times, which one has to be evaluated? In this case, since the precedence of 2 operators are having the same value, hence we need to go to the associativity. So let us consider back the table. So in the table we can see that the associativity for the dollar symbol to be evaluated is right to left. Moving first we will start from the right side and then we will go to the left side. So in the same case, if we do consider here in this example, so it is to be conducted from right to left. So the rightmost side we have the expression y dollar or y raised to z. So hence we will evaluate y dollar z or y raised to z. So substitute y dollar z as t1. So here t1 is what? Y dollar z. Convert it into the postfix form, it will be yz dollar. Okay. Next we have the expression x dollar t1 minus m plus n plus p divided by q. Here anyway among the other operators, dollar or caret symbol is having the highest priority, hence we will substitute x dollar t1 as t2. So t2 means what? X dollar t1. Convert it into the postfix form, it will be x t1 dollar. Okay. Next we remain with the expression t2 minus m plus n plus p divided by q. Among minus and plus and division symbol is having the highest priority, that is 4. Hence we will evaluate p divided by q at the first stage. Now we will substitute it as t3. So t3 means what? P divided by q. Convert it into the postfix form, it will be pq divided by. Okay, right. Next we have the expression remained as t2 minus m plus n plus t3. Here minus, plus and plus operators are having the same precedence and associativity tells that it should be evaluated from left to right. Hence we will evaluate first t2 minus m. We substitute it as t4. So t4 value will be what? It will be t2m minus, after converting into the postfix form. The remaining expression is what? T4 plus n plus t3. Here it will be considered from left to right. So t4 plus n will be evaluated first. So t5 will be written as t4n plus. Okay, t4n plus. Now next we have a remaining expression as t5 plus t3. So that will be converted into postfix form. It will be t5 t3 plus. Now substitute the values of t5, t3, t4, t1 and t2. We will get the required postfix expression. Now here we are substituting the values of t5 and t3. t5 is nothing but t4n plus and t3 is nothing plus pq divided by. We are substituting both, and lastly it should be plus here, but it is not being printed, it is misprinted. So here we have to keep it as what? Plus, right. Next, substitute the values of t4. t4 value is what? t4 value is t2m minus. t2m minus. Substitute that and keep n as it is, plus as it is, p as it is, q as it is, division symbol as it is, and our plus symbol as it is. That is to be made correct. Okay, right. Then substitute the value of t2. So t2 is what? Nothing but t1, sorry, x t1 dollar. So x t1 dollar I am substituting at the place of t2, and rest of the expression will remain same. And finally substitute the value of t1. So t1 value is what? yz dollar. So substitute here, x is as it is, yz dollar is substituted, and again the rest of the expression will remain. So finally after substituting all the values, we will get this required expression. So this is the resulting postfix expression of the infix expression what is being mentioned here. Okay, right. Now we understood using mathematical way how we can do substitute the values and convert it from infix to postfix. Now let us discuss about how we can write a program to convert the given infix expression to its equivalent postfix form. Now let us understand that. For this, here we are taking the special table consisting of the symbols, the stack precedence function f, input precedence function g, and as well as the associativity, So here in this table we have the different symbols available and their precedence values available. So these precedence values are available based on appearance of the symbol in the stack position or else appearance of the symbol in the input function position. So here function f and function g are taken with different values, and similarly the plus symbol or minus symbol will be either holding value 2 or 1 based on the appearance of the symbol either in the stack or either in the input expression. So based on that this table is designed. So whenever the plus or minus symbol is available in the function f, that is at the stack, then it is taken as value 2. If similarly plus and minus are appearing at the input expression, then from the function g we will take its value as 1. Similarly, we have different values being given for the symbols like asterisk or a division symbol, dollar symbol and raised to symbol, operands, opening parenthesis, closing parenthesis and hash value, and accordingly we are using the associativity of the expression, how it is to be evaluated. Now let us understand the steps what are being required to convert from infix to postfix. There are basically very simple steps available. Before that, this whatever the contents available in this table are written in the form of a C function, wherein we are using the switch condition for switching the different cases. So here symbol is taken as the character to store the data. So plus, minus, asterisk, division, these are all characters, hence we will take the symbol as character, and based on switching of those character we are going to switch the different values. If a plus and minus will appear, we will take it as 2. If asterisk or division symbol appears, we will take it as value 4. If a caret symbol or a dollar symbol will appear, we will take it as value 5. So if the case like opening parenthesis will come, we will take the value as 0. If the case is hash, then it returns what? -1. If none of the symbol appears, if none of the symbol among these listed are appearing, other than that it will be appearing what? Operands. At that time defaultly we will return it as 8. In the similar way, according to the g function what is been listed here, same values are written here in the function g. Okay, right. So you can now ask the question, why the return type int is been taken. Every time when you see the return value is of type what? Integer, either 2, 4, 5, 0. So these are all what? Integer values. Since every time the return case is the integer value, hence we will take the return type of the function as int here in both f and g. Next, let us understand now the procedure to convert from infix to postfix. Basically there are 3 steps that is we are going to use to convert from infix to postfix. So as and all, the precedence value appearing on the top of the stack is greater than the precedence value of the input symbol, then in that case we are going to pop the element from the stack body and we are going to place it in the postfix expression. Okay, so similar code here we are going to write. If the precedence at the top is greater than the precedence of the symbol received from the infix expression, then we are going to pop the element from the top and place it into the postfix expression. Okay, right. So we will understand once we will go with the solving the problem practically. So based on that you can understand this code more easily. Okay, right. The next step tells that if the first condition is not satisfying, either if the precedence of the symbol on the top of the stack is not equal, or either it might be less than the precedence of the symbol in the infix expression, then what we have to do is we have to push the symbol what is that we are reading from the infix expression into the stack body. Or in the other case, if two of the conditions what we mentioned earlier fails, it means the precedence of the symbol in the stack and the precedence of the symbol received from the infix expression both are equal, then what we are going to do is we are going to delete the item from the stack body and we are going to ignore those symbols. We are going to ignore what? Those symbols. We are not going to consider them. Okay. So this will be very much more clearer when we do solve certain example. So let us solve an example. So here we have an infix expression available. So we are going to consider that. Let me move to the particular application. So here I have already evaluated the content. So the infix expression what we are taking is this one. So we are going to apply the three steps what we have taken as an algorithmic part. Okay, we will apply that algorithm and we will try to convert the expression from infix to postfix. So for this, getting the postfix expression, we will consider these following columns. So first one is the stack column we are going to consider. Next one is what is the topmost element in the stack, that symbol we will represent here in this column. Next, the symbol received from the input infix expression. So this is the infix expression what we are going to scan each time. Okay. So each time whenever I am scanning, what symbol is going to appear at that time. So that is that we are going to write in this column values. Okay. Then we have the column where we are comparing the precedence value of the top and the precedence value of the infix symbol. Okay, infix symbol received from the input infix expression. Both we are comparing, we are writing the values. If either three steps, whichever will be satisfied, based on that, either we move the element from the top to the postfix, or we will move the element from the symbol to the stack body, or we will ignore it. Okay. So let us consider first at the initial stage the stack will be at -1. So this -1 is represented by the hash. Hence we will take the first as situation where the stack is having the hash symbol. So stack is having only the hash symbol available. Hence at the top of the stack will be hash. So the first infix expression symbol what we are going to read is opening parenthesis. So we have kept it here in the symbol column. Compare the values between hash and opening parenthesis. Hash is having the value -1, whereas opening parenthesis is having the value what? 9. Okay, it is having the value what? 9. You can just compare it back in the table what is been listed here. Hash value is what? -1, whereas opening parenthesis value is what? 9. Okay. So we have to consider this is something what we are representing it either as F, and we are taking the symbol as what? G. Okay. In the F we have what? In the F we have hash value as -1. You can see in the F we have hash value as -1, whereas in the G the opening parenthesis value is what? 9. So those two values here we are comparing. Is -1 greater than 9? No. So first condition fails. It will go for the second step. Second step tells that if the precedence value at the symbol is having the higher value than the precedence at the top of the stack. So 9 is greater than minus 1. At this case, we have to push the symbol received from the input infix expression into the stack body. So in the next second step, I am pushing opening parenthesis in the stack body. So in the stack body, we will be having two elements, that is hash and opening parenthesis. For your case, I am going to increase the size. So we will be having in the second step hash and opening parenthesis. At the top of the stack, we are having opening parenthesis. Hence, we will write the same in the top of the stack, that is opening parenthesis. Next, after opening parenthesis in the input expression, what we have? We have another opening parenthesis. Okay. So the opening parenthesis value in the f is what? In the f it is 0, and whereas the opening parenthesis in the g is what? 9. So here 9 is having the greater value, hence again we will push the symbol infix input expression symbol into the stack body according to the second step or second step in the algorithm. So in the stack body, what we will be having? Previously we had hash and opening parenthesis. Again another opening parenthesis got added here. Now the top of the stack is what? Opening parenthesis, and in the input infix expression we have the next symbol a. It is written here. So the opening parenthesis in the function f, it is the function f, the opening parenthesis value is 0, whereas the precedence value of a in the function g is what? It is operand we are going to take. So its value is 7. Is 0 greater than 7? No. Again here we are going to apply the second step, that is we will push a into the stack body. So the content of the stack here will be this one. Top of the stack is a, so here we will write again the top of the stack as a here, and the next input symbol is what? Plus. So plus we are going to write here. Compare between the values a and plus. The operand value in f is what? The operand value in f is 8, and the plus value in the function g is 1. Okay. So here is 8 greater than 1? Of course yes. So here we can apply the first step. The first step tells that if the precedence value in the top of the stack is greater than the precedence value of the symbol in the input infix expression, then we have to pop from the stack body and place it into the postfix expression column here. So I am going to pop out a and place it into the postfix expression column. Okay, we are going to place it in the postfix expression column, right? So after popping out a and placing it in the postfix expression, this is the resulting elements in the stack. Top of the element is what? Opening parenthesis we will keep as it is, yet the process of plus is not completed, we have to compare. The opening parenthesis value is 0, whereas the plus value is what? In the g is what? 1. Is 0 greater than 1? No. We have to apply what? The second step. So we have to push plus into the stack body. So the resulting stack elements will be this. Top of the stack is plus. So here we will write it here in this column. And the next symbol what we have in the input infix expression is what? This opening parenthesis. We will keep it here. Compare between the plus and opening parenthesis. Plus value is 2 in the function f, whereas opening parenthesis value is 9. Is 2 greater than 9? No. We have to apply what? Second step. So push opening parenthesis in the stack body. So my stack contents will be what? This one. So the top of the stack is what? Opening parenthesis, and the next symbol that is scanned is b. We are going to write it here. Compare between the opening parenthesis precedence value and the precedence value between b. So the precedence value of the opening parenthesis in the function f is what? 0, whereas the precedence value of the b in the g is 7. Is 0 greater than 7? No. Hence we will push b into the stack body. So my stack contents will be these. So the top of the stack we have b. So b will be placed here. So the next symbol available in the input infix expression is what? It is minus. So we are going to write here minus. So compare between b and minus. So b value in the top of the stack is what? 8, and whereas the minus value is what? 1. Okay. Is 8 greater than 1? Of course yes. So here we are going to apply the step number 1. Step number 1 tells that if the precedence value of the symbol in the top of the stack is greater than the precedence value of the symbol in the input infix expression, that is symbol received from the input infix expression, then we have to pop the element from the stack body, then we have to pop the topmost element in the stack body and place it into the postfix expression, that is the resulting expression will be what? A and B. So in the similar terms we are going to check out all the terminologies in the expression, and finally we will get the resulting expression here. Okay, so resulting expression will be this one. Compare this resulting expression after applying the algorithm and compare that with the evaluated mathematical way. Okay, if they both produces the same result, then we can confirm that the algorithmic part what we have wrote is correct. So here we have the expression available here, a b c minus d asterisk plus e raised to f and then plus. Compare it with this expression. Here again also we have the same expression, resulting postfix expression, that is abc minus, d asterisk plus, you can see here d asterisk plus e raised to f and then plus, e raised to f and then plus. We are observing that the solution that we got after evaluating or after converting infix to a postfix by applying the mathematical way or substituting the values, and by applying the algorithm we are getting the same solution. Hence we can say that the algorithm what we have written, the programmatical function what we have written for the function f and function g, and the priority values are correct. Okay, right. So this was for the expression with the parenthesis. You can apply this same algorithm to convert from infix to postfix to another set of example, that is without parenthesis. Okay, without parenthesis also you can apply, and I hope you will get the same solution. So that is available here. So here we have the infix expression available without parenthesis. Apply the same procedure. So the first symbol, default symbol we have is hash. Okay, the top of the stack is also hash, and then the first symbol input is x. So compare between hash and x. Okay, what we are going to get? Hash value in the function f is -1, whereas the x value is what? 7. For confirmation you can just go back to the table what we have studied here, and then you can observe. The hash value is in the f function is what? -1, and whereas the operand in the function g is what? 9. So here also we have kept the same. Sorry, operand in the function g is what? 7. Okay, so operand in the function g is what? 7 here. Operand in the function g is what? 7, and then hash value is what? -1. So we have kept the same. Is -1 greater than 7? No. Hence push the symbol x into the stack body. Which step it is? I hope you remember it is the second step. Okay, if the precedence value of the symbol received from the top of the stack is less than the precedence value of the symbol received from the input infix expression, that is x, then we will push the symbol x or else the symbol from the input expression to the stack body. So resulting we have pushed the x into the stack body. Top of the stack is what? X. What is the next symbol available? Raised to symbol or caret symbol. Caret symbol available. Compare between x and caret symbol. X value in the f function is what? 8, whereas caret symbol value is what? 6. Is 8 greater than 6? Of course yes. So pop x, apply the first step of the algorithm, pop x and place it in the postfix expression. Okay, right. So once we pop x, the remaining stack content will be only hash, top of the stack is hash, and yet here the raised to symbol to be processed. Hash value is what? -1, whereas raised to symbol value is what? 6. So as compare, -1 is not greater than 6. Then here we have to apply the second step, that is we have to push the raised to symbol into the stack body. After pushing the raised to symbol, we have the resulting stack content here. So the top of the stack is what? Raised to symbol, and then the next element is what? Y. We are going to write it here. Compare between now the raised to symbol and the y. The raised to symbol in the function f is what? 5, whereas the symbol y will be having the value what? 7. Is 5 greater than 7? No. According to the algorithm, we will follow the second step of the algorithm. That is, we will push y into the stack body. So resulting contents of the stack body will be hash, raised to symbol, and y. Top of the stack is what? Y, and then the next element available in the input infix expression is what? Dollar, or else the raised to symbol. Compare between y and dollar symbol, or else raised to symbol. Y value in the function f is what? 8, whereas the raised to symbol value in the function g is what? 6. So is 8 greater than 6? Of course yes. So accordingly to the step number 1 of the algorithm, it says that pop the highest precedence value from the top of the stack and place it in the postfix expression. So the resulting postfix expression will be x and y. So apply this algorithm for the rest of the contents. So we will get in the last the expression as x, y, z 2 times raised to symbol m minus n plus p q division symbol and then plus. Compare with the expression that we got resulted after applying the mathematical way. Here also we have x, y, z 2 times raised to symbol or dollar symbol, and then m minus n plus pq division symbol, and as correction here it should be plus. So after comparing the mathematical approach and the programmatical approach, we are getting the same solution. Then we can say that the algorithm what we have written to convert from infix to postfix is correct. The algorithm what we have written to convert from infix to postfix is correct. Okay, right. Now we are going to conclude this video. So in this video we understood about the applications of the stack. So in the applications of the stack we saw about how to convert an expression, that is from infix to postfix expression. So in the next video we will try to check out about how to convert from infix to prefix, and further we will continue with the rest of the applications of the stack, that is recursion and other more applications and evaluation of the expression. So till then, take care, bye bye, and keep supporting and checking out all those videos whatever I will be posting in my channel, and do subscribe and like my videos. Thank you, take care, bye bye.